Okay, time to turn this purple rectangle into a snake. So, step 1, increment our version number. Let's rip out our snake segment code and make it its own function, because it's going to become a little more complex now than just sticking everything in the door function. So let's take out this. Actually, that can stay for now. Let's rip out this. And let's say draw segment and send it the index for the segment so that we know which one we're drawing. We can tweak this to just be a normal for loop in a minute. Then below draw, we make a new function. We call it draw segment. We send it an index. And we use that index to grab a local variable. It's going to be called v, just so that we don't have to alter the code too much. There we go. Is going to be from snake at index. Okay. If I did my job, nothing will change. Okay. We're still drawing the snake by its segments the way we're supposed to. Okay. Now, instead of just drawing purple rectangles, we need to draw circles, but not just a single circle. We're going to draw a series of circles covering the entire length of that segment. So firstly, let's make this seg. We need to calculate where this segment of the snake starts and ends. So start y is equal to seg dot y position minus seg dot y dir, because we need to know where the segment would start. In other words, from where we're starting the animation. Then we also need an end y, which would be seg dot y position. Both of these need to be in pixels rather than grid coordinates, so let's pass it to our grid function. Okay, and then what do we do with this? We make a for loop for the y variable. We start it at start y to end y, and to iterate it, the step size will be seg dot y direction, because start y is the current position minus the direction. So direction would be -1 in a normal, but actually if we're moving up, yes, it would be -1. So our start y position would be positive from our end direction, because it'll be its current position, say 14 minus y direction, so minus, so plus 1. So the segment, the grid space below it. So the difference would then be -1. So we go from the bigger number to the smaller number going down. 2. And if we're going down with our snake, then it's the other way around. So then this is the smaller number, this is the bigger number, and the y direction is positive. So smaller number, bigger number, positive. Bigger number, smaller number, negative. Because that's a minus, so it inverts the symbol. And for now, circ takes an x-coordinate, which, because we're drawing in the y-axis, the x-coordinate isn't going to change. So it'll just be the grid of seg dot x position. The y direction would be whatever we just calculated for y. The color would be I broke it. What am I missing? Circ. Oh, radius. I forgot to send it a radius. So radius would be half of cell size. Maybe we should just have a global calculating the... Hey! Okay, tiny issue we have here. Besides that, I think I just broke the thing. Yeah, I froze it. Ha! I froze it. Okay, now that I've restarted load snake. Now that I've restarted TIC-80, we need to prevent it from freezing if I turn to the right. Draw segment. And to do that, we actually need to calculate, because this is essentially just looping the same number and never, because we can't do a y direction if these two numbers are the same, because you can't, a loop with a step size of 0 is an infinite loop. So we actually need to go if seg.x direction is not equal to 0, then otherwise we go in the y direction. Okay, let's try that again. I broke it. I'm missing an end. I fixed it. Okay. So the snake is drawing, but the snake is drawing to the left because circ takes a center point with a radius. So the center point is now going to be the top left corner, so we need to add an offset. So let's do below border. Let's make center is equal to cell size divide by 2. I'm going to divide it by 3 so that the snake is a little thinner. Grab center. So what this is going to do is offset our segment by... No, wait. For it to be the center, it has to be half. And then seg size, cell size divided by 3. Okay, so to get the center of a cell, we need half of the cell, and then I'm going to make the segment size a third of a cell so that it's a little smaller. Okay, so draw segment, then it'll be circle x position plus center, y position plus center, and then instead of cell size divided by 2, we go seg size. That's better. Now if I turn to the right, nothing's going to happen because we're not drawing our snake segments there. Okay. So we do the same thing, but for the y-axis. For the x-axis, and then this would then be underscore x, and this would be the grid of seg.y position, like that. Oh, but then we also need to calculate start x and end x. So we can probably destroy this rectangle code now, and then local start x equals and local end x equals, and it'll be this same line and this same line, but for x, x, x. Okay. So now, what did I do wrong? As soon as it turns to the right, string for limit must be a number. On line 150, line 150, start x and x. There we go. Okay. Now to make this snake, at the moment we're just drawing a bunch of circles going from where it used to be to where it is. But to make it look like it's moving, we need that tail to shorten as the head moves forward. So to do that, okay, we know the only thing that's changing between frames is t. T reduces. So on the first tick, t is 6. So 7, yeah, 7 goes through, then 6, then 5, then 4, then 3, then 2, then 1, then 0, in which case we move the snake again. So if we want our tail to get shorter as t reduces, we need to have a cutoff and only draw the circles below that cutoff. So let's start by adding a cutoff. It starts at cell size. This is going to be a smaller inner loop that we're going to use to not break this loop, but to stop drawing. Let's use y first, because then we'll see the results more immediately because we're moving in the y-axis. If we're passing an index, right? Yeah, we're passing an index. If index is equal to the length of snake. Okay, we know if we are drawing index the length of snake, we're busy drawing the tail. And if our cutoff is less than t, then we know we should be drawing. Else, if index is not equal to the length of snake, then we draw as normal. In other words, if we're busy drawing the tail end, we use this code. If we're busy drawing any other segment, we just draw it as normal without caring. But index is equal to snake, it means we're drawing the tail end, but we only draw it if it's below cutoff. And to make that more clear, which one's which, let's make, what color is the head of our snake anyway? It is 7. So let's make our snake 7. So it's a normal color. Oh, right, I'm halfway through code. And then we only draw that, make it purple. End expected to close function at line 139. So somewhere if, for, else, for, if, and then, else, then, end. What was this one? No, wait, this is drawing Y. Okay. And then this is the end of draw segment. Maybe I should just add some comments to everything. So for Y, drawing in Y direction. Only drawing tail if below T. Drawing all other segments. Okay. So now it's not drawing the tail at all. Oh, it is kind of. What's going on? Oh, because that's moving horizontally. Okay. So if I'm not mistaken, we are not drawing the tail at all at the moment. Let's see. The snake should get one shorter now. It does. Okay, so we're not drawing the tail at all because we're not influencing cutoff. Cutoff will always be larger than t. So at the end of this for loop, we need to go cutoff is equal to cutoff minus 1. I hope this is the right spot for it. There we go. Look, the tail is getting shorter. Tick, 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 tick. The tail is also being drawn over the snake because that's supposed to be looping the other way. So let's quickly go back to draw. And instead of just drawing these in any random order, we are going to draw them for I is equal to the length of snake, going down to 1, iterating negatively. Okay, there we go. Now it's drawing the snake segment underneath, and it is reducing as the cutoff is reducing. Tick, 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 tick. How do I explain what's happening here a bit better? Okay. Let's drawing only the tail. Okay. Debug trace. Debug trace. Let's output T. Let's debug trace cutoff. Oh, let's call it cutoff. And then in here we go debug trace draw. Okay, so we should have T and cutoff happening every turn, but if it is the tail segment, then it should only draw tail if cutoff is below T. And oops, and what did I do now? And obviously it should only do that in debug mode. So tick, 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 tick. So look at what output. Okay, where do we move the head? There we go. Snake head changes direction. Then T is 6. Cutoff is 7. So because it's over T, we don't draw that particular circle. Then on the next loop, T is still 6 because we're still within the same frame. But now because we're drawing the next circle, we hit the cutoff check again, and now it's 6, so we do draw it. Then 5 draw it, then 4 draw it, and so on and so on and so on. Then we go to the next frame. So now, wait, where's that's other segments being drawn. Oh, right, because we're only printing this when we're printing the tail. Okay. So we only draw the frames, we only draw the circles up to T and no further. Now we can do that same thing with the head, so that the head extends, but we need to do it the other way. We need to only draw it if it's over cutoff. Oh, and obviously we need to do this for the x coordinates as well. So let me just grab this. Put it in here. Index is not equal to the length of snake. Then we draw as normal. There is an end there. Okay, but this has to be that line. And then inside this for loop, there is a missing. Oh, this needs to be indented. That's why. And then after this, cutoff is equal to cutoff minus 1. That'll be 7. That'll be 1. Run. So that works for horizontal. For vertical. Now we turn horizontal. And now theoretically, when it turns, it turns. Okay, so if I now make that tail segment the same color, it should just look like it's moving. Look at that! Ignore the head doing the popping thing. Just look at the tail. Look there. Tick, 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 tick. It just looks like the snake is moving, even though the entire middle section of it is not animating. Only the tail is animating, but your brain does the work to make it look like the whole thing is moving. Now we have to do the same with the head, but it's essentially the reverse. We have to draw the ones larger than T so that it slowly extends along with where the head of our snake is going. First, let's... Actually, this is fine. But now we need to check only when it's the head. So here else if index is equal to 1 and cutoff is greater than t, then only draw head if above t. And then same code to draw the head, stick it in there. And now let me just get this turned around. It's not doing anything. Else if and index is not equal to 1, then we draw as normal. There we go. Look, snakehead is moving. But now it looks like his eyes are a little bit too far back. And also we need to rewrite this to be for the x coordinates as well. So this else if needs to come with me to here. The tabs here are weird. There we go. And it needs to be the same line as this one. There. And then this is if index is not the last one and index is not 1. Okay, so now it'll work going to the right as well. It does not. But why? Because I misspelled the name of a variable. There we go. Hey! Okay, but something looks weird with the eyes being so far back. So let's tweak this guy to be a bit closer to the front. Like a bit shorter and maybe a little closer to the front. This first row of pixels we can ignore because we're working on 7 by 7 and this is an 8 by 8 sprite. Same here, bring the eyes a bit closer, move the whole head up to the top edge because we're still ignoring this part and this part. For this one it works the other way, ignoring this part and this one. Move the eyes a bit forward and move the whole thing to the edge. Now it's a cute little short snake. But now also the turn looks more realistic. This is almost turning into a snake game. Okay, but what about the tail? The tail is just blunt. Look at this. Does this look like a snake? Does this look like the tail of a snake? No, it looks like a worm. But we can probably draw the tail end the same way that we draw the head. So, please hold. Okay. And then in draw, the same way that we draw the head of the snake, we can draw the tail of the snake. But now it'll be snake local tail is equal to snake. Unfortunately, this one we cannot calculate ahead of time because the snake is going to change length. So hashtag snake the length of snake will be different every time. So we do need to calculate tail every time. Oh, and this will be tail x, x, tail, tail. And then the frame would be... Oh, we have a problem. Not all snake segments have a direction, have a getDir function. So at this point we're creating the snakehead as a separate object and giving it the function getDir, and then making the rest of the snake segments using the factory, the function that creates new snake segments. But there's nothing special about snakehead except that it has an x and y direction, which on the first tick it gets from newDir anyway. So why can't I just make snakehead using our function and then give all of them this getDirection function? So let's take this, get rid of this, get rid of this, just tell it snakehead will be, what's it called? New segment at 215. That's what it was, right? And then snakehead is equal to snake 1. That should, oh, snake underscore head. That should restore everything. Except that now new segment, our function new segment, needs to give all our segments that function. So segment dot, and then all of this code, which should be generic because it's just referring to self. Ooh, and one dot. Okay, so all our segments will now have a getDirection function, meaning we can now draw our 3-pixel tail piece. Unless I broke something, we're looking for a global new segment. Line 36, go to line 36, new segment. I can't call that function until the thing is initialized. So let's take these out. Actually, let's leave snakehead as undefined, and then in here do this. Add our first segment to our snake, set snakehead, and then continue normally. Whoa, what is going on up there? We don't need that. Is that what was causing it? No. Why are we drawing snakehead twice? Oh, because that's our tail. The tail pixel is actually at 272. Firstly, go to draw, find where we draw snake tail. It's at 272, and clearly we are miscalculating something about the tail. Tail x grid, tail x position, tail dot x direction, and tail y. There we go. Now our snake has a teeny tiny little tail. Do you know what would make this look even more impressive? Is if I take away the grid. So let's quickly grab this grid, draw grid if debug mode, then draw grid, and then make a new function here, call it draw grid, stick this in here. In other words, our grid will only appear when we're in debug. Hey, that looks cool. We do need to still draw a square on the outside of the board. There's our grid. It pops up as soon as we go to debug. and then it goes away again. But we will need to draw something, so let's just draw a rectangle from border and border. It'll be cell size times, what do we call it, board width? What did we call it? Grid size. Grid size, and the color we make six. X, Y, width, height, color. Oh, this needs to be in here twice. Oh, that's very green. But it works. We're going to have to tweak these colors a little bit, but we'll do that in the next one, along with starting to worry about the snake moving like a snake is supposed to move. Finally, we're getting into the game mechanics of Snake, now that we have our snake drawing properly.